I'm Anil Kumar. Welcome to my series on functions. Now we have an application and thinking question based on quadratic functions. This question has been picked up from previous test paper. A high school is planning to build a new field surrounded by a running track. The track coach wants 3 laps around the track to be 2000 meters. The football coach wants the rectangular infield area to be as large as possible. Can both coaches be satisfied? Explain your answer. Right? You can always pause the video, answer this question, and then look into my suggestions. So we have this rectangular area. The soccer field is oval in shape, so we'll have 2 semicircles on both the ends. So that is the kind of structure which is going to be made. Now here what we are given is that 3 laps around the track is 2000 meters. Let's say this is the length and that is the width. In that case, the perimeter, let's say P, perimeter will be, so there are 2 L's, that is 2L plus 1 circle, right? So pi times d, right? Diameter here is width, so it becomes pi times w, right? So that is what the circumference of the circle will be. So the formula used for this part is circumference is pi times diameter, or you normally write 2 pi r, correct? Since we know that this is the diameter, half circle here, the half one is there with those centers, width as w, correct? So we'll use diameter d is w for us. In our case, diameter is w, correct? So we'll replace with this. We are given that 3 laps, that 3 times this perimeter is 2000 meters. So what we are given here is 3 times perimeter is equal to 2000 meters, right? So P should be equal to 2000 divided by 3. So let's substitute this value in our equation. So we get 2000 divided by 3 is equals to twice length plus pi times width. Now from here we can isolate one of the variables and then work with the other one. The idea is to maximize the area of the rectangular field. Alright, so we need to maximize this area. So the question is to maximize area. Let's say we call this as area A. So area is length times width. So we need only one variable, so let's isolate length from here. So in that case, we get 2000 over 3 minus pi w equals to 2 times length, or we can say length is dividing both by 2. We get 2000 divided by 6, right? Minus pi w divided by 2. So dividing both by 2, we get this expression for length. Now we can write area by substituting this value of length, let me call this as 1, in our equation number 2. So we get area as equal to, instead of length, I will write all this, right? So what we get here is 2000 over 6 minus pi w over 2, so that is length, times width. Now this is like a factored form, right? Quadratic equation in W, right? This is quadratic equation in W, right? This is a quadratic equation. So how do we get maximum from here? Well, clearly it has 2 zeros, as you can see from here. We have 2 zeros. So if I am going to plot this, 1 0 is that W equals to 0. So this is width for us and that is area for us. So if I plot it, I get two zeros. One of them will be at 0. So the 0, because of the position W, one will be here. The other one will be because of this factor, correct? So the maximum will be where? Maximum will be right in the center, right? So maximum will be same distance from both, right? So we are looking for this value of A max. You get the idea. So that is how we are going to use this strategy to solve this. So let's find the other 0. So 2000 over 6 should be equal to pi by W over 2, right? So from here we get the value of W as, so we can write W as, so 2 times 2 over pi, right, times 2000 over 6, right? So dividing this by 3, we get this as 2000 over 3 pi. So this is this value. This value here is 2000 divided by 3 pi. So the center value will be average of these two, right? So the width for maximum area will be what? Will be 0 plus, this is 0, this is that much, right? 2000 over 3 pi divided by 2 or times half, correct? So that gives you, when you open this up, you get 1000. 2000 divided by 2 is 1000 divided by 3 pi, clear? So we get the width for maximum area. Now let's find the length also. So length will be how much? Length is 2000 over 6 minus pi times W over 2. So the length will be 2000 over 6 minus pi times W over 2. Let me write pi by 2 first, right? Pi by 2 times W, which is 1000 over 3 pi. So pi and pi cancel. So we have same denominator of 6. 2000 minus 1000 is 1000. So we get here 1000 over 6, which is same as 500 over 3. Is that clear to you? Right? So that helps us to get both the values. So we get our solution. And let me push this a bit in front. So what we get here is for maximum area, width will be equals to 1000 by 3 pi, and length equals to 500 by 3. Is that okay? Sometimes you may be required to find the maximum area, which will be product of these two. Is that clear to you, right? So that is how we get our solution. Hope all the steps are absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.